So, I heard you're curious about what is machine learning engineering. So today I'll try to cover this topic in 30 minutes or less. We will give an overview of what is machine learning, what are the challenges that you can face with machine learning, what is machine learning engineering, and what skills are necessary for a successful machine learning engineering. My name is Eduardo Bone. I'm a full stack developer here at GitLab on the MLAPs area. So first of all, what is machine learning? That is the main question that we have to answer before understanding what machine learning engineering is in the first place. Machine learning is a way that we can instruct a computer to a machine or to learn how to make estimations or predictions or recommendations based on past data. Data here can be images, text, events, clicks, anything that you can convert in a format that the machine can understand. I like to say that machine learning is basically an automated informed guesser. So it tries to guess something, and the better data it was displayed before, the more informed the guesses are, and the best the guesses will be. So if you think about, if you replace the entire conversation that we have forward machine learning by informed guesser, things will make a lot more sense even. So with this, let's give an example. Suppose that I have this dog and I want to create an algorithm or a way to detect not only for this dog but for any image whether the image is a cat or a dog. So what I'm going to do, for this I'm going to need a machine learning model. A machine learning model will make this prediction for me. And for me to create a machine learning model, the first thing that I need is the data. So I have to collect a lot of data on dogs and cats so that I can show the machine so that it can learn from this, they learn the difference between both. Once I have all this data, I can apply a machine learning algorithm on top of it, and then that will create a machine learning model that will be able to, given an image, give a probability of whether that's a dog or a cat. For example, this is a 70% a dog. So, very quickly, brief explanation of machine learning, of course, but some terms that might get you confused. Machine learning and artificial intelligence, for example. Artificial intelligence is a superset of machine learning. So machine learning is part of artificial intelligence. Artificial intelligence is not a way, but the studies on how to reproduce human intelligence on a machine. And there are many ways to do that. Machine learning specifically is how to do this by looking at past data or past experiences. And the second one that you see a lot happening is the difference between machine learning and statistics. And the reality is that no one really knows the difference actually. So it's just two names. They use the same tooling. They solve very much the same problems. There are subtle differences sometimes. They say, okay, statistics is more academical. They are more theoretical, while machine learning is more practical, more empirical. But in the end, they are just the same thing. Machine learning is even called sometimes statistical learning. So, yeah, don't bother with these discussions. So now that you have some idea of what is machine learning, well, very briefly, of course. What are some of the challenges when once you create a model or once you are trying to solve a model with machine learning? What are some challenges that you can face on the process? So the first one is data. A model is like any machine learning product that is created is just as good as the data that is fed into it. That is where it's trained. So you cannot create a really good model, from bad data. The data must have high quality, meaning it must capture all possible events, all possible classes. It must be fresh. So if the data is too old, the machine learning model will not be able to reproduce or make good predictions. You need to give access to this data somehow, somewhere. The infrastructure around providing this data as well, both about collecting the data, about providing the data, about labeling this data. So getting the data right is one of the major challenges with machine learning. The second one, after you have the data, is model creation. And here's the biggest challenge for in all machine learning development, is to know what needs to be created in the first place. How can you answer a business need with, how can machine learning answer a need your business has? How can we create a profitable, a product that can really impact users, or that really solves a problem that users are having or businesses having, or anything like that. Then, once you know what problems need to be solved, then you have, for example, data processing. How do you pick up the data? How do you pre-process this data? Is this data, how can you maintain the data? How can you version the data? Then you have the problem of which machine learning algorithm you're going to apply. There are many algorithms out there. Each one solves a specific problem. Choosing the correct one might make a lot of difference, and it's just not choosing the algorithm that brings the best results. There are a lot of constraints around. For example, processing power. How much time does it take to train the model? How much time does it take to hyperparameter tune? And things like that. And then also metrics. So a machine learning model is created to solve a problem. You only know if you're actually solving that problem if you have metrics to measure. So for example, if I want to create a recommender system like Netflix, the recommender system specifically exists to solve a user need, which is find stuff we like, but it needs a metric that the model can translate and can understand. So for example, for Netflix, it could be number of hours watched per user, or time spent browsing. You want to help users spend less time browsing the catalog, for example, and more time watching. And then once you created the algorithm, then the next challenge is about model deployment. There's a huge difference between creating a model and creating a model that goes into production and goes and is used by users. So you have to scale that model. It's not only one person that is accessing the model. It's not the model creator that is accessing the results, the predictions of that model, the guesses of the model. Is thousands, millions, billions of users that might be using that output. So scaling is really complicated. How do you update your models? How do you version your models? How do you monitor them? How do you know they're doing the right thing? How can you make deployment easy without a lot of errors throughout it? So this is another entire set of challenges with the development of machine learning. So you have and another one that is more, we are getting more and more worried about, is about privacy and ethics involved with machine learning. So privacy means, like, what are you going to do with the data? Sometimes you can extract information that was used to train the model from the results. And that is very complicated. How does privacy play with it? Also, ethics. How is this model used? Is this model, even models created with really good intentions, they might backfire and create societal changes. For example, it can, models, like machine learning models, they replicate the biases that exist within the data. So if you feed in biased data, it will give biased predictions. For example, if for police use case, for facial recognition, if it uses only the pictures of people who are already arrested, it might create a bias towards minorities. And that is very complex, and it's not a trivial solution to work on. It's a discussion that is gaining a lot of light recently, and it's a very important discussion to have. So this is another thing that we need to worry about. So this is just a very quick overview of what might be some of the challenges. So it's just to give an idea of what the complexities are within developing a machine learning model. Now that we know this, we can explore a bit more on what is a machine learning engineer. Here we had the challenges, right? And usually what happens is that, at least in this division, you're going to have one profession specialized on each one of these areas. So for example, the data side, you're going to have a data engineer that is specialized on how to move data around, how to collect data, how to label data. For the model creation, you're going to have the data scientist, which is a person that knows how to create models, how to answer business needs, how to talk to the business, and how the best machine learning algorithms to use, how to create metrics, and so on and so forth. And on the last one, the model deployment, that's what the machine learning engineer comes in. So it is a software engineer that is specialized into deploying machine learning models. That is what a machine learning engineer is. And note that privacy and ethics are part of are equal parts of everyone. So note that this doesn't mean that a machine learning engineer will never work with model creation or data. Quite the contrary. It's quite common for a machine learning engineer to go and create a simple model. It's quite common for the machine learning engineer to go and have to create the data pipelines. It's just that that's not the focus. A machine learning engineer is about deploying those machine learning models. Even if they create the model, it's not where they will spend most of the time. They will just create a model that will be 10% of the work, and then they will try to dedicate as much time as possible into deploying that model. Same thing with data. And that is also valid for the data scientist and for the data engineer. Sometimes the data scientist needs to work on deploying the model. But usually, since machine learning engineer is specialized in this, their solutions will be more scalable, more maintainable, and so on and so forth. Now that we have this, so this is what I said before. So a machine learning engineer is the software engineer specialized in putting machine learning models into production. And I would like to emphasize here that it is a specialization of software engineering. So this is the work of a machine learning engineer. It is a software engineer. It's just that they work on this niche that is machine learning. So they will deploy systems, they will create systems, they will create scale system, they will design systems that are specialized in machine learning, in putting machine learning models into production. Now, to cover those areas, what are the skills necessary for a successful machine learning engineer? That's another important question to have. Like I said, going from this slide that we showed before, these are the main some of the main problems that a machine learning engineer will face. So what are the skills necessary to tackle those problems? So first of all, the first part, software engineering. This is the core of machine learning engineering. This is where a machine learning engineer needs to spend most of their time studying, of course. While not mandatory, first of all, Python. Python, you can create an editing language, but Python became almost the lingua franca of machine learning. You have R and you have other languages that are used for deployment, but Python is the one that is used everywhere. So if there is one language to choose from, choose Python. And second is how to write maintainable code, so testing code, modularization. Something that happens a lot with machine learning engineers is how to move code from Jupyter notebooks into pure Python, for example. It is very common for the data scientists or even for the machine learning engineers to create the models in Jupyter notebooks, but Jupyter notebooks don't play well with production environments, so it's often common for the machine learning engineer to move from Jupyter notebooks into pure Python. So also system design, how to design scalable software. So like I said, it's different to create a small website that runs on your laptop to creating a website that runs for millions of users, right? Same thing. So it's very different to create a machine learning model that runs for one user and create a scalable pipeline where millions of users can use that machine learning model. It's also really important to use to understand cloud computing. So how to create a system. This is part of the system design. What are the concepts that are common across the big vendors? How to set up a small system, how to put a website online, things like that. It's very important to be familiar with. In the second area, you are a machine learning engineer. So even though it is a specialization of machine learning, it is important to know machine learning. So first of all, it might be weird, but it's really important actually to know linear algebra. Computers understand data through matrices, through numbers and vectors. And most machine learning implementations are actually matrix operations in some way or another. It's just multiplying large matrices. So an image is just a matrix of numbers between 0 and 255. And you use these representations to fit into machine learning models. So understanding linear algebra and working well with linear algebra is quite important actually when you're implementing new machine learning models. Another one is data munging. By data munging, I mean how to clean up the data, how to select the correct features for the model, how to do feature enhancement. This is a bit more towards model creation. Most of the things here on the machine learning area are about a little bit more about model creation, but you need to understand this in order to implement this on your final system. So it's not like you cannot just clean the data and then that just lives on the Jupyter notebook and then you just send the model. No, that data needs to be cleaned on production as well. So you need to understand the algorithms that are used and how to implement them. It's also important to understand the different tools that are used. For example, TensorFlow, Scikit-learn, PyTorch, each one of them has their own peculiarities, had their own use cases, and each business need might ask a different implementation, for example. And on top of understanding the tools, it's important to have knowledge on the different algorithms that can be used. So for example, there we have neural networks, decision trees, XGBoost, and many others. Each one of them has their pluses and minuses. Sometimes it's a very simple algorithm, but it runs really fast. Sometimes it's a very slow, it's a very good algorithm, but it depends on a lot of data. So choosing the right algorithm will depend on the use case and on the restrictions around. Evaluating machine learning models is also very important over here. So how do you know that your machine learning model is doing the right thing, right? So you created a machine learning model, you deployed it, and then what? Is it working as expected? Is it bringing value? Is it decreasing the value of the tool? How can we know if one machine learning model is better than the other? How can we understand the long-term impacts of that machine learning model? And then finally, ethics and privacy. I already mentioned this a bit, but it's really hard to find a book or something on this topic. It's hard to study this, but it's really important to be aware of how over the news and how models that are created with the best intentions can actually create really bad changes that were unexpected beforehand. And the next one, the next area of skills is around MLAPs. So DevOps is about making it easier to deploy applications. And similarly, MLOps is about making it easier to deploy machine learning models. So how to automate the deployment, how to create an architecture where we can quickly ship a model into production. What are the patterns that the community uses? For example, pipelines, model registry, feature store, prediction service, and so on and so forth. I'm not going to explain any of them. It's not on the scope of this presentation. My goal is actually just to drop the names, and if you're interested, you can search online later on. And I gave here some examples. Note that I don't endorse any of these tools, except of course GitLab, but they're just examples that are there. I don't know if they're good or not, or I have no goals of this. It's just they're just examples. And yeah, so where do you get these skills? There were many. I said a lot of words so far, but how can we go about going after this knowledge? So some books that I recommend, I added over here. This machine learning engineering book I really enjoyed it. It's a short book. It doesn't go in too much depth on each topic, but it looks at machine learning from the software engineering perspective. So most books that you're going to find around are actually looking at machine learning from an academic perspective or from the model creation perspective. Here, not so much. It's about the engineering problems and the engineering issues that are around. And I wouldn't spend too much time studying algorithms or going too deep into the algorithms, because as a machine learning engineer, of course, you must know, and it will always help knowing more and more about the machine learning. But over time, you don't gain so much about getting too deep into machine learning algorithms in itself. It's better to just understand the applications and the downsides of each one, rather than really understanding in depth each of them. So focus on the concepts. So instead of studying one, trying to understand all of the different model registries, understand why a model registry is necessary. Why is it over there? What problem does it solve? Rather than on implementation. So okay, you have MLflow, you have Comet, you have Seldon, you have many model registries, but they all solve the specific problem, and it's important to understand what is the problems that they are solving. And that's it. This was very short, and I tried to give just a quick overview, just to give a taste of what machine learning engineering is. And my goal is just make you curious. So if you're curious about this, this was supposed to be one way of just dropping the word, so that if you're interested, you can have a point of start of what to look for when you are trying to increase your skills in this area. So thank you for joining, and have a great day.